Hello and welcome back to the Deep Dive. Today we're getting into something really interesting, foundational learning in programming, specifically Python, and importantly, how it connects right from the start to, well, AI. Our source material for this is some excerpts from a learning program called Python Programming Day 1. It sounds basic, right?
Yeah.
But it's designed specifically to welcome newcomers into coding. So our mission here is to really unpack its core promise. How does it actually try to make these, complex topics feel approachable? Okay, let's dig in.
Yeah, and what's really fascinating, you see, is how this day one material doesn't just say it'll be simple. It seems to jump right into the why of it all. It shows how even, the most basic Python concept connects directly to something important in AI. It's definitely about building that solid foundation step by step. And it seems aimed at literally anyone, total beginners, or maybe someone just wanting a new skill. The key thing is making sure you get the what and its why for AI right from the get-go.
Okay, that's quite a promise, isn't it? Making AI feel approachable literally from day one.
Looking at these excerpts, can you pinpoint a specific exercise or maybe a concept they use that really shows that immediate link between basic Python and an AI application?
Oh, absolutely. A really clear insight from this day one stuff is how it introduces something like variables. Instead of just saying, here's a variable, it holds stuff, it frames them as the fundamental building blocks for handling data in AI. So for instance, it might explain assigning a number to a review score, maybe 1 for positive, 0 for negative. And it says that is the very first step towards building, say, sentiment analysis AI. So you're learning a really basic Python thing, but bam, you immediately see how it's used in machine learning.
Okay, yeah. That really connects the dots, doesn't it? Takes it from abstract to something tangible. What about another piece, like logic or decision-making in code? How does day one handle that and link it to AI? Because I definitely remember that being a bit of a hurdle when I first started coding. Logic can feel tricky. Right, yeah, that's often a sticking point. And this material seems to tackle it head on. It moves past just variables into simple conditional logic, your basic Eiffels statements. But again, it's not just about the syntax. It frames these as the core decision-making engine for an AI. An example they might use could be showing how an AI decides if an email is spam or not spam. Fundamentally, that relies on these kinds of conditional checks. Or maybe they introduce something like a for loop, not just as a way to repeat things, but as the actual mechanism an AI uses to sift through, thousands of data points to spot patterns or maybe train itself. It's all about showing the immediate practical use of every basic concept within that AI context.
So it sounds like the program's real strengths, maybe its genius, isn't just what it teaches, but how it forges those connections so early on. It's like it's demystifying the past towards understanding these big, complex systems right from the very beginning.
Exactly, precisely. By grounding these very early concepts in direct AI applications, it sort of shifts the learner's whole mindset. You're not just memorizing syntax, you're starting to understand the purpose behind it, the power it unlocks. And that's just crucial, I think, for actually retaining the information and maybe more importantly, feeling empowered, not just, overwhelmed by abstract rules. It really seems to deliver on that promise, simplifying the journey by constantly highlighting that essential why.
Right. So wrapping this up, what does this all really mean for you, the listener? This deep dive into Python programming day one suggests that getting good at foundational coding isn't just about learning the rules of Python. It's about seeing, right away, how those rules apply to powerful fields like AI. The program seems very explicit about helping you understand the why behind the what's. And that approach could really make all the difference in truly getting a new skill, not just learning it.
Yeah, and that brings up a really interesting question, I think. If the entry point, the very first steps into powerful technologies like AI can be made clearer, more accessible, just by directly linking those basic concepts to real-world applications, to that why, then what other complex fields, maybe things you thought were out of reach, could actually become accessible too, simply by finding and focusing on that fundamental why right at their core, something to think about. Okay, let's get straight into it. Today we're doing a deep dive into, Python. Why is it such a big deal in tech right now? We're pulling insights from the source, the case for Python, simplicity, versatility, and value. And our goal here is pretty simple. Break down why Python stands out so you can really get a handle on its significance fast.
Yeah, and understanding Python's value, it's more than just looking at code, is that it really shines a light on major tech trends. And importantly for you, the career paths it opens up. It's pretty fundamental to how things work today. digitally speaking.
Right. So how does one language end up seemingly everywhere? I mean, startups, massive companies, they all use it. Let's start with that famous simplicity. Our source says the syntax is almost like reading plain English. That sounds amazing, especially for beginners. But like, what's the real impact of that beyond just being easy?
Well, the key thing there, the takeaway, is that the clarity isn't just about making it easy to learn. It's about efficiency, big time.
Mm.
Python's design, it really cuts down that learning curve, so you get to focus more on the logic, the problem-solving part. Instead of getting bogged down fighting with complicated syntax rules, it's a kind of simplicity that really fuels faster learning and maybe more importantly, faster development for everyone involved.
Okay, faster development, that makes sense. But its appeal is obviously much broader than just being easy to pick up. What really seems to push it over the top is its versatility. The source points out it's dominant in like the biggest, most impactful fields right now: AI, data science, web development. How did it manage to get its fingers into so many different pies?
It's fascinating, actually, if you connect this to the bigger picture. Python is genuinely at the heart of innovation in so many areas. Just think about the systems recommending movies on Netflix, right? Or the algorithms in self-driving cars. Even the heavy-duty analytics driving business choices, or the back-end stuff running lots of websites you use daily. Python's a major player in all of that, which naturally creates this huge range of career options for you. It's also, well, mind-boggling how one language touches so much.
It really is staggering when you list it out like that. Okay, so it's simple, it's versatile, but what gives it staying power? What makes it a solid long-term bet for developers? I guess that leads us to the community and libraries aspect. The source mentions this is huge. For someone maybe just starting out, what does that actually mean day to day? How does it make coding easier beyond just, oh, you don't start from zero?
That's a really good point. So this ecosystem, it involves this incredibly active community. People constantly sharing tips, helping each other out, building new tools. It's very supportive. And then you have this vast collection of pre-written codes, these libraries. It means, practically speaking, you rarely have to build common functions yourself. Need to work with data. There's pandas, right? Build for that. Want to get into AI? You've got TensorFlow, PyTorch, these really powerful frameworks for machine learning. They're ready to go. So it's not just about saving time, though it does that. It also frees you up, lets you concentrate on the unique, the interesting parts of whatever you're building.
Right, leveraging the work of others. Okay, makes sense. And let's be practical. For a lot of people listening, the bottom line is, does this translate into good career prospects, high salary skills?
Exactly. And the answer is, well, yes. What's really compelling is that Python isn't just some general skill anymore. The demand, especially for people skilled in AI and data science applications using Python, is consistently outstripping the supply of developers. And that scarcity, combined with the strategic importance of these roles for businesses, it directly leads to really competitive salaries, good career growth too. So it's less about just learning any language and more like you're investing in a skill set that industry really, really needs right now, and likely for the future too. It feels quite future-proof.
So tying it all together then, what does this all mean for you, the listener? We've seen Python's simplicity makes it easier to get started and build faster. Its incredible versatility puts it right at the center of really cutting-edge technology. And then that huge community and library ecosystem, it just accelerates everything. And all that adds up to skills that are genuinely in high demand and highly valued.
Absolutely. And maybe a final thought to leave you with. Consider how Python, as this sort of foundational tool, isn't just changing technology. It's subtly influencing so many parts of our daily lives. Think about how we get entertained, how companies operate, even how research is done. So maybe ask yourself, which of these areas where Python is making a difference sparks your interest the most? Where might you want to maybe dive in a bit deeper?
Okay, let's unpack this. Think about your day so far. Did you maybe use a map app? Or scroll through social media? Or maybe ask a smart assistant something?
Yeah, probably all three for many people.
Right. These things feel so seamless, we kind of take them for granted, but there's this incredible tech hidden underneath. And, what's the surprising link between so many of them?
That's the question.
Well, today we're doing a deep dive into Python, that really versatile programming language, and its reach. It's surprisingly pervasive across, well, almost every industry and app you interact with. We're pulling from the source Python's pervasive reach, real-world applications.
And our mission here really is to pull out the key insights from that source.
Yeah.
We want to help you really grasp why this one language, Python, has become so foundational to, well, our whole digital world.
Yeah.
It's not just theory, right? Its influence is profoundly tangible. You feel it every day.
Absolutely. So let's maybe start where its impact is super visible right now, cutting-edge AI.
Good starting point.
When we talk about things like ChatGPT, these incredible systems that, understand and generate text that sounds human, a big part of that, the natural language processing, leans heavily on Python.
It really does. Its ecosystems, especially with libraries like TensorFlow and PyTorch,
Yeah.
it just lets developers build and scale these complex AI models so much faster.
It's like the bedrock for a lot of modern AI development.
Exactly. And what's fascinating is how it provides this really robust infrastructure. It's not just for little scripts, It scales. Think about Google.
Right. Massive scale.
Yeah, Python is used extensively there for critical internal systems, loads of data analytics, even core parts of their search engine. It's just really efficient at processing these huge data sets. Perfect for that scale.
And it's not just search at Google, right? Doesn't it stretch into YouTube too?
Oh, absolutely, which just shows its adaptability. On YouTube, they use Python for like video processing pipelines and crucially for that powerful recommendation engine.
So when YouTube somehow knows exactly what video I want to watch next.
Python's deeply involved there.
Yeah.
It's tailoring that whole experience for you.
And that versatility, that personalization, it's not just Google. Netflix is another huge example, isn't it?
Prime example.
Yeah.
The recommendation engine, heavily reliant on Python, making sure you always have something new suggested based on these complex algorithms crunching your viewing habits. And they also use it for data analysis, monitoring systems, even parts of their content production workflow. It really contributes to that smooth, personalized feel you get.
Okay, shifting gears a bit. What about other big industries like automotive?
Yeah, its reach goes there too.
Yeah.
Deeply. Think about Tesla.
Right.
They use Python for internal systems, sure, but also for collecting and analyzing the just vast amounts of data streaming from their cars.
Wow.
And even in developing some of their autonomous driving features, running complex simulations, it's directly pushing forward self-driving tech.
That really highlights that blend you mentioned, powerful but also developer-friendly.
Exactly. And that leads perfectly to something like Instagram.
Yeah.
Hugely popular platform.
Billions of users.
And it's largely built on Python. Specifically, they leverage the Django web framework for their backend.
Django, right. Heard of that.
Yeah, Django's got this batteries included approach, meaning it helps developers build these complex, scalable applications really fast. That's how Instagram handles millions of users, processes tons of data, connects people globally so quickly. Python makes it efficient. So you see, Python isn't just like an academic thing or only for beginners learning to code.
No, clearly not.
It's this unique mix of versatility, this huge library ecosystem, and importantly, it's readable code. That makes it the true backbone of so many innovative, widely used technologies today.
It really is amazing how it connects so many dots. You've got AI understanding you, like ChatGPT.
Yep.
Netflix suggesting your next show. Tesla advancing autonomous cars.
Right.
And Instagram connecting pretty much everyone. Python's reach is just, well, undeniable.
It's everywhere.
So maybe next time you're interacting with, your phone, your computer, whatever, just take a second. Reflect on how something as abstract as lines of code, like Python code, can so profoundly shape almost every digital interaction you have. Understanding these foundational technologies, it really does change how you see this modern, connected world we live in.
Welcome back to the deep dive. So you've probably written some Python code, right? Or at least seen it.
Oh, absolutely. It's everywhere.
Exactly. And you hit run and stuff happens. But have you ever really stopped to think about how? How does the computer actually take your script and, do things?
That's the mystery we're digging into today. We want to pull back the curtain on how Python code actually executes.
From script to output.
Precisely. We'll map out, conceptually anyway, a kind of three-step flow from the code you write through the magic in the middle to the final result you see.
Okay, sounds good. So step one is, well, it's the code itself, isn't it?
Yep. There, your Python code, just the instructions you've written down.
Could be super simple, like print something, or maybe a really complex calculation handling data.
Right. Whatever the task is. It's your blueprint written in Python's, fairly readable style.
Okay, blueprint handed over. What's next? This is where the magic happens, I guess.
This is the crucial part. Step 2. The Python interpreter. Now, what's fascinating here is how it works. It's like a a highly intelligent translator.
A translator.
Yeah, because Python is generally interpreted. It doesn't usually get turned into raw machine code all at once like some other languages.
Right, not compiled in the same way.
Exactly. The interpreter looks at your code, often line by line, or at least block by block, and translates it on the fly.
So it's like having someone whispering the translation in real time to the computer who only speaks binary.
That's a pretty good analogy, actually. But there's a slight nuance, an intermediate step that's quite important.
Oh, okay, tell me more.
Well, the interpreter doesn't usually translate directly to machine code instantly. First, it compiles your Python code into something called bytecode.
Bytecode, okay, heard of that. What is it exactly?
Think of it as a kind of low-level, platform-independent set of instructions. It's optimized, but it's not machine code yet. It's code for the Python virtual machine, or PVM.
Ah, the PVM. So, interpreter makes bytecode, then the PVM runs the bytecode.
You got it. The PVM takes that bytecode and then executes it, translating those bytecode instructions into the actual commands your computer's processor understands, and doing it as it goes.
Okay, so that two-step .code to bytecode executed by the PVM, that explains the interpreted feel. It's flexible.
Very flexible. Quick development, dynamic typing, all that good stuff stems from this.
But does that interpretation, that extra layer, ever slow things down compared to, say, C++ fear?
Yes. That's the trade-off sometimes. There can be a performance hit compared to code compiled directly to native machine language. The PVM adds a layer.
Right.
But for many, many applications, Python's speed of development and the power of its libraries totally outweigh that. And lots of those libraries, they have C code under the hood for the heavy lifting.
So you get the best of both worlds sometimes.
Kind of, yeah. And understanding this bytecode and PVM step is super helpful for debugging, too. When you see an error trace.
You're often seeing where the PVM tripped up on a specific bytecode instruction. Okay, that makes a lot of sense. So code in, interpreter translates to bytecode, PVM executes bytecode. Which brings us to step 3.
Step 3. The output. The whole point, right?
Yeah, the result. What you actually see or what actually happens.
Could be anything. A message on the screen, a number calculated, a file created, maybe a web page updating.
The tangible effect of your code running.
Precisely. That's the end of the line for this particular flow.
So let's recap this core idea then.
It really boils down to this. Code goes in.
Your Python script.
The interpreter processes it, creating bytecode.
Which the Python virtual machine executes.
Nice. Output comes out simple on the surface, but quite elegant underneath. That's how your Python programs spring to life.
Code in, interpreter, and PVM process, output out, a clear flow. And you can see why that makes Python so dynamic.
It really does. And maybe something for you to think about now that you have this perhaps slightly clearer picture of the bytecode and the PVM working behind the scenes. Does understanding that internal mechanism change how you might think about writing your Python code? Or maybe how you approach debugging, or even, optimizing for performance?
Welcome to the deep dive. Have you ever, installed Python, thought everything went fine, then tried to run a script and just nothing, like command not found? It's super frustrating.
Oh, yeah, that's a classic one.
Exactly. So today, we're diving into why that happens. We've got this really clear 3-step guide as our source and our mission. Pinpoint that one step you absolutely can't miss if you want to avoid those headaches later.
Right. Let's get into it.
Okay, so step 1, according to the guide, is actually pretty simple. It's just getting the installer file. You just go to the official site, python.org, find the downloads page. And the cool thing is the site's usually smart enough to figure out if you're on Windows or Mac OS or Linux.
Yeah, it usually suggests the right version, the latest stable one.
Exactly. So you just click, download. Not much drama there usually.
No, that part's generally smooth sailing. But then comes step 2. And this is where our deep dive really matters. When you run that installer you just downloaded, you'll eventually see a screen, maybe with some options, and there will be a checkbox. It usually says something like, add Python to path.
Or maybe add Python to environment variables.
Right, same idea. And checking that box, it's absolutely critical. You really want to make sure that's ticked.
So let's talk about why it's so critical. What is this path thing anyway, for someone who might not know?
Sure. So the path is basically a list your operating system keeps. It's a list of directories where it looks for executable programs.
Oh, okay.
So when you type a command, like Python, in your terminal or command prompt, the system scans through the folders listed in the path to find a program named Python.
And if the folder where Python installed itself isn't on that list.
Then the system says, sorry, I don't know what Python is. Even though it's installed, it just doesn't know where to look.
That makes so much sense. And checking that box during installation automatically adds Python's location to that system list, right?
Exactly. It tells the system, hey, whenever someone types Python, you should check this specific folder too. And suddenly it works from anywhere.
Which is huge, because it means you can just open your command prompt wherever you are, type Python, or like pip install something.
Yeah, pip2, the package installer, that also needs to be findable.
And it just works? No navigating to weird program files, folders, or anything.
Precisely. It seems small, but skipping it is honestly the source of so many problems later on. People trying to use IDEs, virtual environments.
Right, their code editor can't find Python, or installing packages fails. It all comes back to this.
It often does. And yeah, you can fix it manually later if you forget.
But it's a pain, right? You have to go into system settings.
It's definitely more complicated than just clicking the box during the install. Much easier to just get it right the first time.
Okay, makes sense. So, kick the box, critical step done, then what? Step 3 is just checking it worked.
Yep, verification. Once the installation says it's finished, you just need to confirm 2 things. 1, that Python is installed, and 2, that the system can find it because it's in the path.
And how do you do that?
Super easy. Open up your command prompt, that's CMD on Windows or Terminal on Mac or Linux.
Okay.
And just type Python, then a space, then 2 hyphens, and the word version. So Python version. Then hit Enter.
Python version. Got it.
If you see something pop up like Python 3.1.4 or whatever version you installed,
Then you're golden.
then you're golden. It means Python is installed and your system knows where to find it from anywhere. That little check mark did its job.
That's brilliant. It really shows how, like, one tiny click during setup can make such a huge difference in how easy or hard it is to actually use the tool later.
Absolutely. It's not just about following instructions blindly. It's understanding the why. Knowing why adding to path matters gives you that power. It makes things much smoother.
Yeah, it transforms it from just a checkbox to, like, actual useful knowledge that helps you avoid real frustration. So what's the big takeaway here?
Well, I think it highlights how these foundational things, these little setup details we might rush through, can fundamentally shape our whole experience with technology.
That's a great point.
It makes you wonder, doesn't it? What other small, maybe overlooked settings or concepts are out there quietly influencing everything you do on your computer, just waiting for you to understand them and unlock a more efficient way of working? Welcome back to the deep dive. So, you've done it, you've got Python installed, fantastic first step. But there's always that immediate next question, right? Okay, now where do I actually write the code?
Exactly. Where does the magic happen?
Today, we're going to dive into exactly that. Taking your computer from just, having Python to having a really intuitive, powerful Python workspace.
Yeah.
Our mission here is simple. Demystify setting up your code editor. We're focusing on Visual Studio Code, VS Code.
Good choice.
And we'll show you it's actually a surprisingly simple 3-step process, get you coding efficiently.
And that's the key, isn't it? It's moving beyond just a basic text editor you might have used.
Right.
A well-set-up environment like VS Code, it's not just for typing. It really becomes like a co-pilot for your Python journey.
A co-pilot, I like that.
Yeah, it transforms the editor into what we often call a first-class Python development environment, which basically means it understands Python. It helps you out, anticipates what you need. It seriously boosts your productivity, makes the whole experience, just better for you.
So it's like less frustration, more actual coding.
Precisely. Think of it maybe like upgrading from, a standard car to one with all the driver assists, GPS, everything integrated. Smoother ride, gets you there faster.
Love that analogy. Okay, so let's get into the nuts and bolts of this upgrade. How easy are these 3 steps? Step 1 sounds almost too easy.
It really is straightforward.
Just download VS Code itself. You head over to code.visualstudio.com. The site's pretty smart, usually figures out if you're on Windows, Mac, Linux.
Right, it usually auto-detects.
And there's just a big download button. Click it. That's it.
That's pretty much step 1, yeah. The goal is just get the file onto your machine, no hoops to jump through.
Okay, download complete. What's step 2?
Step 2 is installing and opening it. And honestly, if you've ever installed any software, this is going to feel very familiar.
Standard procedure then.
Exactly. You double-click the file, you download it, you get the usual prompts. Next, finish kind of thing.
Agree to the terms you haven't read.
Well, yes. But the default settings, they're usually perfectly fine to just get started.
Good to know. Don't need to fiddle too much.
Nope. Once it's installed, just launch VS Code. You'll see the interface. Often it's dark themed by default these days. Clean slate.
All right, so VS Code is open. Now, step 3. This feels like the important one for us Python folks.
This is where the magic really happens for Python, yeah.
Yeah.
Step 3 is installing the Python extension.
Okay, how do we do that?
So inside VS Code, look on the left-hand side. There's a sidebar with icons. You're looking for one that looks like 4 squares kind of snapped together, maybe one breaking off.
The extensions icon. Got it.
Click that. A search bar will appear at the top of that panel. Just type Python.
Simple enough.
And you should see the official one from Microsoft pop right up. Big name, usually says Microsoft on it. Click the install button next to it.
Okay, clicked install. Now, why is this the game changer you mentioned? What does this extension actually do?
Okay. So this extension, this is the core of that first-class environment idea. It's not just a small add-on. It fundamentally changes how you interact with your code.
How so?
Well, think about intelligent code completion, or IntelliSense, as they call it.
Complete, basically.
Sort of, but much smarter. It understands Python syntax, knows your variables, your functions, the libraries you're using. It suggests completions as you type, cuts down errors, saves looking things up constantly.
Okay, that sounds genuinely useful. What else?
Then there are the debugging tools, really robust ones.
Bug hunting. Always fun.
Well, this makes it less painful. You can set breakpoints to pause your code, step through it line by line, inspect the values of variables at any point.
So instead of just printing everything to the console.
Exactly. No more print, am I here? Variable value. You can see what's happening inside your running code. Pinpoint bugs way faster.
That alone sounds worth it.
Right.
Especially for beginners.
Absolutely. And there's more. It helps with code formatting, keeping your code looking neat and consistent.
Yeah.
Following Python style guides like PEP8.
Automatic.
Often with a keystroke or on say, yeah. Plus, linting. That's like a grammar checker for your code. It flags potential errors, style issues, even before you run it.
Wow. Okay. So it's like having a proofreader over your shoulder.
A very helpful, non-judgmental proofreader. And one last big thing, it helps manage different Python versions and virtual environments right within the editor. If you work on multiple projects, this is huge.
Right. Keeping dependencies separate. Okay.
So yeah, install that extension and you are genuinely ready. Your editor now understands Python.
Okay. So let's wrap this up. The main takeaway here seems to be that getting a really powerful coding setup for Python using VS Code, it's actually not scary.
Not at all. It sounds like a lot, maybe, but it boils down to those 3 steps.
Download VS Code, install it,
Yep.
add that one crucial Python extension.
Boom, you're set.
And suddenly you've got all these powerful features, the code completion, debugging, linting right at your fingertips. You've put the power to write code efficiently right in your hands.
And thinking bigger picture, this ease of setup, it really lowers the barrier. Lets people jump into programming without getting totally bogged down in complicated configurations first.
Right. Less fighting with the tools, more actual thinking and creating.
Exactly. You get to focus on the problem solving, the creativity, the fun part of coding. Instead of wrestling with setup, it frees you up to just build things.
Which leads us to the final thought for you listening. Now that your workspace is set up, truly ready for Python, what incredible things are you going to build? Welcome to the deep dive. Today, we're really getting into something foundational, that moment where code stops being just text and actually does something. We're going to walk you through writing your very first Python program. Our guide here is based on excerpts from your first Python program, Hello Future.
And it's such a key moment. It really is where instructions, they come alive. It's where the dialogue with the machine begins.
Okay, so let's dive in. First things first, you'd probably be in something like VS Code, right? You open a new file.
Yep, a blank slate.
And you save it, maybe as hello.py. That .py part is important now.
Absolutely crucial. That tells your system, tells the Python interpreter, hey, this is Python code you're looking at. It sets the context.
Got it. And then comes the magic line, the one everyone starts with, pretty much. Print, hello, future.
Right, the print function. And it seems so basic, but let's unpack that print bit for a second.
Okay.
It's a built-in function in Python. Think of it like a ready-made tool in the Python toolbox. Its specific job: to display stuff.
Display stuff where?
Usually onto your screen, like in the terminal window or an output panel in your editor. It takes whatever you put inside those parentheses, makes it visible. It's the program talking back to you.
Okay. So it's like the computer's voice in a way.
It's first voice. And it's designed to be easy. It handles different kinds of data pretty smartly, turn it into text you can read. Very Pythonic, readability.
Right. Makes sense. And the hello future part, that's just text.
We call that a string, basically a sequence of characters. And those quote marks, single or double, Python doesn't mind, which are non-negotiable.
Why is that?
Because they tell Python, treat this literally. This is just text. Don't try to figure it out as a command or a variable name. Think of it like putting quotation marks around something you're quoting in an essay. It signals this is verbatim text.
Okay, like a label saying, just display this.
Precisely. Without the quotes, Python would try to interpret hello and future as maybe variables or functions, and it would just break, give you an error straight away.
Right. So you've got your file saved. You've written print, hello future. Now you want to see it work. How do you do that?
Several ways, usually. In VS Code, there's often a nice green run button, like a little triangle play symbol. Super easy.
Click and go.
Yep. Or you might find it in the menu, something like run, then run without debugging. Or you can go a bit more old school, open the integrated terminal.
Okay, the command line thingy.
Exactly. And you just type Python followed by your file name, like Python hello.py, hit enter, and bam.
Bam. And that's when you see it, right? Hello future, printed out.
That's the moment.
It's actually quite a buzz, isn't it? Even though it's so simple. You type something and the computer responded. You made it happen.
Yeah, absolutely is. And don't underestimate the significance. Yes, it's just one line, one output. But connect that to, the bigger picture.
How so?
Well, every complex piece of software, every single one started with simple steps like this, that print function. It's basically the ancestor of all the ways programs communicate outwards.
Like logs or messages to the user.
Exactly. Yeah. Debugging information, status updates, user interface text. It all comes back to this fundamental idea. The program needs to output information. That hello future is your program's first utterance, its first signal to the outside world. It's foundational.
Wow. Okay. So that simple print is actually kind of a big deal conceptually. You've literally opened a communication line.
You really have, which leads to a thought you can mull over.
Oh, yeah.
If one simple command like print lets your computer speak to you, what other simple foundational commands might let it, say, listen to you? Or maybe even make decisions based on what it hears or sees?
Like inputs and logic.
You got it.
Yeah.
Think about how these basic building blocks, these simple instructions, start to combine to create, everything complex we see in software today. It all starts here. Welcome back to the deep dive. So you've probably written some Python code, right? Or at least seen it.
Oh, absolutely. It's everywhere.
Exactly. And you hit run and stuff happens. But have you ever really stopped to think about how? How does the computer actually take your script and, do things?
That's the mystery we're digging into today. We want to pull back the curtain on how Python code actually executes.
From script to output.
Precisely. We'll map out, conceptually anyway, a kind of three-step flow from the code you write, through the magic in the middle, to the final result you see.
Okay, sounds good. So step one is, it's the code itself, isn't it?
Yep. Your Python code, just the instructions you've written down.
Could be super simple, like print something, or maybe a really complex calculation handling data.
Right. Whatever the task is. It's your blueprint written in Python's, fairly readable style.
Okay. Blueprint handed over. What's next? This is where the magic happens, I guess.
This is the crucial part. Step 2. The Python interpreter. Now, what's fascinating here is how it works. It's like a highly intelligent translator.
A translator.
Yeah, because Python is generally interpreted. It doesn't usually get turned into raw machine code all at once like some other languages.
Right, not compiled in the same way.
Exactly. The interpreter looks at your code, often line by line, or at least block by block, and translates it on the fly.
So it's like having someone whispering the translation in real time to the computer who only speaks binary.
That's a pretty good analogy, actually. But there's a slight nuance, an intermediate step that's quite important.
Oh, okay. Tell me more.
Well, the interpreter doesn't usually translate directly to machine code instantly. First, it compiles your Python code into something called bytecode.
Bytecode. Okay, heard of that. What is it exactly?
Think of it as a kind of low-level, platform-independent set of instructions. It's optimized, but it's not machine code yet. It's code for the Python virtual machine, or PVM.
Ah, the PVM. So, interpreter makes bytecode, then the PVM runs the bytecode.
You got it. The PVM takes that bytecode and then executes it, translating those bytecode instructions into the actual commands your computer's processor understands, and doing it as it goes.
Okay, so that two-step code to bytecode executed by the PVM, That explains the interpreted feel. It's flexible.
Very flexible. Quick development, dynamic typing, all that good stuff stems from this.
But does that interpretation, that extra layer, ever slow things down compared to, say, C++ fear?
Yes. That's the trade-off sometimes. There can be a performance hit compared to code compiled directly to native machine language. The PVM adds a layer.
Right.
But for many, many applications, Python's speed of development and the power of its libraries totally outweigh that. And lots of those libraries, they have C code under the hood for the heavy lifting.
So you get the best of both worlds sometimes.
Kind of, yeah. And understanding this bytecode and PVM step is super helpful for debugging, too. When you see an error trace.
You're often seeing where the PVM tripped up on a specific bytecode instruction. Okay, that makes a lot of sense. So code in, interpreter translates to bytecode, PVM executes bytecode. Which brings us to step 3.
Step 3. The output. The whole point, right?
Yeah, the result. What you actually see or what actually happens.
Could be anything. A message on the screen, a number calculated, a file created, maybe a web page updating.
The tangible effect of your code running.
Precisely. That's the end of the line for this particular flow.
So let's recap this core idea then.
It really boils down to this. Code goes in.
Your Python script.
The interpreter processes it, creating bytecode.
Which the Python virtual machine executes.
Output comes out simple on the surface, but quite elegant underneath. That's how your Python programs spring to life.
Code in, interpreter, and PVM process, output out. A clear flow. And you can see why that makes Python so dynamic.
It really does. And maybe something for you to think about now that you have this perhaps slightly clearer picture of the bytecode and the PVM working behind the scenes. Does understanding that internal mechanism change how you might think about writing your Python code? Or maybe how you approach debugging, or even, optimizing for performance? Welcome to the deep dive. Today, we're digging into something really foundational. It's like the day one homework for anyone starting programming, specifically setting up Python and VS Code.
Exactly.
And we're not just going through the steps. We want to explore why these specific initial tasks are actually, well, pretty cleverly designed.
It's easy to see setup as just a hurdle, something annoying you have to get past before the real coding starts.
Right. Get it over with.
But getting this environment set up correctly and verifying it works, that's more than just avoiding errors. It's really about building the right mental framework from the get-go.
Okay, so let's break that down. The sources really hammer home this primary task. Install Python and VS Code.
Mm-hmm.
They call it the foundation for everything else we'll do, and even say, make this your absolute top priority. That feels quite strong for just installing software.
It is strong, but it's justified. Think about how many beginners get tripped up by, path variable issues or installing the wrong Python version.
Oh, I remember those days. Nightmare.
Exactly. So by focusing on getting it right and verified up front, you eliminate maybe, 80% of those initial frustrating roadblocks.
That makes sense. You're clearing the path so the learning can actually happen.
Precisely. It builds confidence immediately. Your first interaction isn't, why doesn't this stupid thing work? It's, okay, step 1, done. It works. That's huge psychologically.
All right, so environment sorted, verified. What's next in this day one plan?
Then you get your hands dirty immediately. The instruction is super specific. Run.print. My name is Raghav. I'm 19. I love AI.
And it walks you through it. Open a new Python file in VS Code, type that exact line.
Yeah, the quotes and parentheses, everything.
Save it, run it. And they even add that little touch. Feel free to replace Raghav and 19 with your own name and age if you like.
That print statement seems almost trivial, doesn't it? But it's doing a couple of really important things.
Okay.
One, it's that immediate hello world moment. Tangible proof that Python is listening and you can make it do something. Instant gratification.
That little win.
That little win. And two, you're practicing using the print function itself, which, let's be honest, is something you'll use for debugging forever, basically.
True. Even experienced devs use print statements all the time.
All the time. And the personalization part. Replacing the name and age. That makes the output yours. It connects you to the code, makes it feel less abstract. It's not just running code. You're running your code that says your name.
Yeah, I can see how that adds a little something extra. Okay, environment, first line of code. There's one more step for day one.
The final piece.
Comment done on the video. Seems like simple progress tracking, right? Check the box.
On the surface, yeah. But there's a community aspect baked in there, and it's quite clever.
How so?
Well, first, seeing others comment done reinforces that you're part of a group. You're not alone on this journey. Second, the instruction often includes something like mention any challenges.
Ah, okay. So it's not just saying you finished, it's opening the door to say, I finished, but this part was tricky.
Exactly. It normalizes asking for help right from day one. It builds a little micro-community around the learning process, making it okay to struggle and okay to reach out. It combats that feeling of isolation you can sometimes get when learning online.
That's actually a really thoughtful way to structure it. It connects the individual task back to a wider group.
It does. It subtly introduces the collaborative nature of tech and coding. You learn, you share, you help each other troubleshoot.
So pulling it all together, what does this mean for you, the listener? These steps, install, verify, print, comment, they might seem small,
Tiny steps.
but the thinking behind them is pretty significant. It's about setting you up not just technically, but psychologically for success.
Absolutely. The takeaway here, I think, is that mastering any complex skill, like coding, really does start with nailing these precise foundational actions. It's not about rushing to the complex stuff.
It's about building solid ground first.
Solid ground, yeah. And the way these instructions subtly weave in personalization and community right from the start, it kind of hints at the bigger picture, doesn't it?
Yeah.
That coding isn't just about solitary typing. It's about creating things that matter to you and often doing it together with others. That journey starts with print. Welcome to the deep dive. Today, we're on a bit of a mission. We want to really pull apart the core ideas for getting good at a new skill. We're looking specifically at learning to code, using this great source about starting out with Python. Our goal, find those really potent insights, the things that can speed up your understanding and help you build real mastery. Not just for code, maybe for anything new you tackle.
Exactly. And this is so important for you, the learner, right? Because you want to soak up knowledge effectively. You want to actually get it without, feeling totally swamped. And yeah, the source uses Python as the example, but the underlying wisdom, it's pretty universal. It's really about how we learn best, how our brains work.
Okay, so let's unpack this. The source jumps right in, zeroes in on something fundamental, daily practice, and it's specific. It doesn't say hours. It says just like 15, 20 minutes a day. And what did you make of that? I mean, is it really that straightforward, or is there something more subtle going on there?
Well, the fascinating thing is the why behind it. Those short, regular bursts. See, learning, it's not really about these massive, heroic efforts. It's more about consistently building and strengthening pathways in the brain. Think of it like, I don't know, compound interest for your mind. Every little bit you put in regularly, it builds on itself. So you end up with way more progress than if you just, cram occasionally. You're building something solid, not just stacking things precariously.
Right, a consistency builds the foundation. Makes sense. But then the source brings up another point. What about sort of the scaffolding, the support structure? That's where lecture notes come into play. It calls them a fantastic resource, good for review, jogging your memory, maybe checking syntax details you forgot. It even mentions the notes of lecture 1 as a specific compiled reference.
Oh, absolutely. Having good detailed notes is, well, it's often really underestimated, I think. It's powerful because structured notes let you fix your own mistakes. Right there, in the moment. You can reinforce a concept immediately instead of getting stuck. That's a common trap early on, right? Forgetting one little thing can just derail you. So notes become this tool for active recall, for coaching yourself almost. It builds knowledge and confidence.
Okay, and then we get to what the source itself calls the most crucial takeaway, which is stay consistent. Mastery takes time. Simple as that. And it's quite upfront about frustration being normal, like it's expected, part of the deal. But the key is meeting that frustration with patience, because that's what leads to progress. It sounds, I don't know, almost too basic, but maybe that's where we often fall down.
Yeah, and if you zoom out, it's really about normalizing that whole learning curve, isn't it, for anything tough? Which kind of leads to a big question for you listening right now. How can you maybe start to reframe those moments when you feel stuck or frustrated? Instead of seeing it as, I'm failing, maybe see it as, okay, my brain is actually working hard right now. It's adapting, it's growing. It's often right at that edge, that point of discomfort where the real learning kicks in.
So taking all this, consistency, patience, using resources like notes, what does it mean for you beyond coding? Think about it. What's one small thing, one daily action you could actually commit to? Could be anything, learning an instrument, a language, even just a healthier habit. Something small, but done consistently. Where could that lead you? Maybe somewhere unexpected down the line.
Because that's what a true deep dive requires, doesn't it? Whether it's into a topic like this or into your own potential. It's not just about gathering the info. It's the consistent doing and having the patience to let it sink in, to really make it your own. That's how information actually turns into real mastery.